In this video, we're going to take a look at how to calculate the distance between any two points or locations mathematically. First, we're going to define the word distance, which is just the length between any two points or locations. Now let's start ourselves off with an example. Given the point -2, -1, and a second point 2, 3, so two locations on our coordinate grid. If we connect those with a line segment, and we were asked, what is the length of this segment in terms of the units on the graph? Well, this segment is arranged diagonally, and it's not easy for me to just count boxes to figure out how long it is. It's not like trying to figure out how I move horizontally. Like if I move horizontally between the 2 points, pretty easy to see, I have moved 4 units left to right. Similarly, if I compared the 2 points and moved vertically, I have moved 4 units vertically, up and down. And drawing those in, notice we have formed an object using that line segment. We've formed a right triangle, which means to calculate the length of that side, we can use the Pythagorean theorem, the theorem that links the 3 sides of a right triangle. A squared plus b squared equals c squared. And in this case, our a and b, the legs, are the horizontal and vertical distances. So we'll have 4 squared plus 4 squared equals c squared. And simplifying from there, that'll give us 16 plus 16 equals c squared, which means c squared is 32. And to get rid of that square and just get our length c, that distance, we take the square root of both sides, and c is equal to 5.657, a result I got just by plugging this into a calculator. And so we can generalize this to work for any 2 points using what's known as the distance formula, which states that any distance d between 2 points will be the difference between the x values of the 2 points, that quantity squared, plus the difference between the 2 y values, or the y distance, that number squared, and putting the entire thing under a square root, which is the same as saying we are taking the square root of a squared plus b squared to give us c, like we did in the example above. In this formula, the a just represents your x distance, and the b represents the y distance. So you can think through the formula as it's written formally, or if you draw it and visualize the right triangle, you can think of it more like Pythagorean theorem, because both are doing the same exact problem. So one more example, let's say we want to find the distance between -1, 2 and 5, 10. Notice no graph, so I'm going to go with the formula that we have up top. Labeling my 2 points, x1, y1, and x2, y2, our distance d will equal the square root of the difference of my x values, so -1 minus 5, quantity squared, plus the difference of my y values, 2 minus 10, quantity squared. And now we just start simplifying. This will become -6 squared plus -8 squared, or 36 plus 64, still under that square root. And our distance will be the square root of 100, which is just the number 10. Drawing these 2 points, they would be exactly 10 units apart. And your goal for this topic that you've just learned about is to make sure that you commit either the formula to memory or the process for using a right triangle in order to find distance.